Okay, so what I wanted to do is just go over the first, few items on Moodle Cloud and make sure that everyone understands how that works, and then as questions come up, I can address those. So just feel free to jump in and stop me whenever something doesn't make sense, or I remind you of something that you were thinking about. Um, just feel free to interrupt me at any time. And let's see, let's take a look at Moodle Cloud. It looks like, I think, pretty much everybody uh, has found their way to Moodle Cloud, so that's good. That's the first step. That's what I check for in these first few days, is to make sure everybody's actually logged into Moodle Cloud and gotten to this course. And then I'd like for you to read the triviality of logic. It's interesting to get that history. Logic is one of the seven liberal arts. The arts or crafts, techniques that makes one free. The liberal arts, and that's sort of the basis of Western education. Is the seven liberal arts, and so we're sort of fulfilling that role of doing our fundamental general education by doing this course. Okay, so I start out here with some familiar lookup tables. Hopefully this isn't anything too mysterious, that you've seen lookup tables like this, and I emphasize lookup tables like this, and I keep on hammering home this notion of a lookup table because many students need that reinforcement, because sometimes when we come to logic, we think that there's some like mystical sort of secret that we're supposed to get, and there's not really that much to get, and the way that you get it, to the extent that you need to get it, is just look at the way these lookup tables function. Pay attention to the way that the lookup tables function. You just look everything up. Everything that we're doing at this point can simply be looked up in the table. So if you just follow a mechanical lookup procedure, then you will get the right answers. There's really no thinking involved, and this is what then shows us that logic is fundamental to the way that computers work. So computer science is based upon this general notion of logic that we're exploring right now in this course, and a computer doesn't think. There's this whole notion of artificial intelligence, but nobody believes that we've actually achieved a machine that has artificial intelligence, at least not the way that we normally talk about it in philosophical discussions. But now we're just sort of talking about artificial intelligence, but all that means is that you have a supercomputer that does a bunch of mechanical processes. The computer doesn't know what it's doing in the way that a human being can be self-conscious and know what they're doing. So and logic is very much like that, especially at this introductory level. You don't have to know what you're doing. You just have to follow the procedure. But the thing with humans is, once we follow the procedure and we get the procedure down and we can do it very accurately, then we quite naturally start to reflect on what we're doing, because we are intelligent beings. And through our natural intelligence, we begin to get it. We become self-conscious of what's happening. But if you feel like you're not getting it, then just stick to the mechanics, because it's the mechanics that is the way that we get the ball rolling. And then once you see how it works and you're very proficient at just going through the motions, then you can step back and you can say, oh, I see how this all works together logically. And you begin to get a logical sense of what's going on. Okay, so that's why I'm emphasizing lookup tables so much, because sometimes, or back in the day, in the past, I've provided lookup tables, and but I didn't call them lookup tables. I just called them tables. And I say, well, the information's there, and I, sort of indicate, well, you can look it up. But then many students will think that there's some way that they're supposed to do it without looking it up. Like they're supposed to know something else besides looking the information up in the table, and they keep on searching for something else. And I'm trying to tell you, don't look for anything else. Just look it up. Just follow the lookup procedure, and that's all you have to do. And everything will work out famously. So I keep on, now I refer to the tables as lookup tables, and I keep on using this word look up, look it up. Here we look it up, we go to this row, we go over to that column. It's a little tedious for those of us who see it right off the bat, but for many of us, it takes a lot of repetition. So I'm just sort of laying that groundwork. So just be patient with that if it seems a little tedious. But also think, you could maybe even train a monkey to do this stuff, right? So it doesn't really require much intelligence, just an ability to go through the motions in some sort of training, sort of trained behavior. Okay, so now I have this yoga schedule here. You look up the times and the places for the yoga classes, and then answer the questions. And I think we've all done that. I assume that you're able to do that, and that you've done that before. And I assume that you've also seen a multiplication table. In elementary school, whenever you learned your multiplication products, you probably saw a table that looks something like what we have here, where everything's arranged in rows and columns, and then you have all the answers to your multiplication problems. So this reduced addition of odds and evens, this is where I want to, give some explanation, because maybe we are not. Maybe here there's some questions that have come up. Okay, let's see. So let's take a look at these problems. So I said I want you to reduce it to odd or even. So in the explanation document, let me go back here. Read these explanations. If you feel like you're not getting a full explanation of what's going on, read the explanations. And I highlight them as explanations so that you get the sense this is the explanation of what's coming next. And it's important to read these explanations so that you understand what's coming next. But really get in the habit of doing that. Sometimes students want to skip the explanations, and maybe that's fine for a while, but at some point it's like, oh, what did I miss? I missed something. Okay, so make sure you're really reading those and thinking about them. I try to keep them very short. I don't give you more information than what's needed. It's just like right to the point. This is what I want you to know right now. do this exercise thinking about this. All right, and I give examples of how to do the exercises. So if the exercises seem a little mysterious, go back and read the explanation right before the exercise. It should clarify. Okay, so make sure you're reading these documents as you go, and then you can mark these. You can check them off as you go down, and as you complete the exercises, these check marks will automatically fill in. So just work down the list in order, and the order of the items here on Moodle Cloud match the order of the assignments as they're listed by date in Canvas. So the ordering in Canvas is the ordering here. At least it should be. If it's not, if I make some mistake, let me know. But that's what I intend, is the list should be the same, and you just go down the list and just work down the list. Okay, so this is the explanation that comes right before this exercise. And so I give you this table right here. So this is the key table that we want to look at in this explanation. And then we're just going to build upon this explanation until we get a whole class of logical operations. And notice how the table is arranged. So I was talking about certain conventions that we use in academic, discussion of logic. And it's especially these conventions have to do with the way that we order the values. So here, when we're talking about this algebra of odds and evens, the values are, there's two. One value is odd and the other value is even, right? So there's only two values in this whole algebra. There's odd or there's even. And by convention, when we're doing this sort of thing, it's usually the case that we put even as the first row, and then we do odd even odd, and then odd. And then this tells us how this operation works. If the left input is even and the right input is even, then it spits out even. And if the right input is odd and the left input is even, then it does odd, et cetera, et cetera. So notice we're thinking about the binary nature of the operation. We're thinking of all the possible combinations for the left and right inputs in terms of even and odd. So these are all the possible combinations in which those could appear. And then here is the resulting output. Notice that I line this up right underneath the operation so that what the operation results in is vertically directly below the operation. So this use of the columns is very important in organizing our thinking about this, but at this stage, again, you don't really have to think that much. You just have to follow the tables, know how to use the tables. If you know how to use the tables, then you're going to get the right answers. And so let's look at this table and see how we get the right answer for that reduction sort of problem by looking it up here. All right, so I'm just going to put these side by side, and we're going to use our lookup table to get the right answer. And let's say that I asked you to do 6 plus 4. All right. And we said, okay, what's that? The way to use the table in doing this is we're going to first convert 6 to even. We're just going to say 6 is even and 4 is even. So we have an even plus even situation. And then we're going to go to the row of the table that has even, even. We're going to go to this first row where it's even, even. And we're going to look under addition, and it tells us 0. So we just go back over here and we say, oh, this is 0. And that's it. If we have something where it's 8 plus 3, we have an odd, or sorry, we have an even plus an odd. And so we go to the 0, 1 row. And again, I know this might seem tedious, but this is what we should be thinking about at this stage. And if you're not thinking in this way, start thinking in this way. You know, there's nothing mysterious going on here. So we go to the 0, 1 row, 0, 1, and we follow that row over to where the addition operation is. So this is just like looking stuff up in the multiplication table or whatever the case may be. And we say, okay, that's 1. And so we could even do it like this. So that's 1. And so on and so forth. Are there any questions about that lookup procedure? I mean, this is really, this is really the way that, the conventions of introductory logic, this is the way it's organized. And this is sort of this should always just be in the back of your mind when you're thinking about the way that logic works. It's like, oh, you just go, you look it up and think, oh, I could program a computer to do this.